Good afternoon, everybody. Hopefully you had a chance to start the do now. This is a reach back to chapter 5, which we were working on last week. We were doing all of the ions and writing the electron configurations, using the noble gas configuration, all that kind of good stuff. If you have an answer, feel free to put it in the chat. I'm going to go over it. The question is asking, which of the following is not isoelectronic with krypton? Krypton is right here. This is group 8A, and it's part of the noble gases. Isoelectronic means that you've got the same electron configuration. If you have the same electron configuration, then that means that you have the same number of electrons. So you can do this problem without actually writing out all of the configurations for these ions. Krypton has 36 electrons. Okay, that 36 means the atomic number is 36, that's the number of protons. And in a neutral atom, the number of protons is equal to the number of electrons. So krypton has 36 electrons. We have to deal with 4 different ions to figure out which one of them does not have 36 electrons. We'll start with selenium 2-, which is right here. On its own, just a neutral atom, it would have 34 electrons. But the charge is 2-, so that means that it gained 2 electrons to become an ion. It's a nonmetal, so it gains electrons to become an ion. So it has 36 electrons, just like krypton does. So that one is isoelectronic. Let's do bromine. We'll do bromine in a different color. Bromine is right next door to selenium. And on its own, it has 35 electrons. To become an ion, bromine is going to gain 1 electron. So it too has a total of 36 electrons. Zinc 2+ is the next option. A regular old atom of zinc has 30 electrons. But zinc is a metal, and metals lose electrons to become ions. So we lose 2 electrons, and we have 28. So far, that's looking like the answer. But for completion's sake, we'll do strontium as well. Strontium starts with 38 electrons. It's going to lose 2 electrons, as indicated by its charge. When it's a positively charged ion, that means it has lost electrons. So 38 is what it starts with. We lose 2. We're at 36. So the only one that doesn't have 36 electrons is C. That's the zinc 2+ ion. Questions? And make sure you can do a problem like this because it will definitely be something you see on the upcoming exam. Now we'll start chapter 6. All of the stuff that we did with the ions last time, you're going to need that in this chapter. So if that was a struggle for you, we'll do a little bit of review, kind of, but you really need to go back and work on that end of chapter 5 to make sure chapter 6 makes sense. So we're talking about the language of chemistry, which is going to lead us into describing the chemical reactions in chapter 7. We first started classifying things when we were classifying matter, and that was way back in chapter 3. And one of the ways that we could classify matter is calling it a pure substance. And within that category, we had elements and compounds. What we're doing today is taking this part, compounds, and breaking it up even more. We can have organic compounds, which we're not talking about, and inorganic compounds. Inorganic compounds typically don't contain carbon. There are a couple of exceptions, which I mentioned in the video. But by and large, you're not going to see carbon in inorganic compounds and acids. The three major groups are ionic, molecular, and aqueous acids. And we're going to break those classes down into 5 common classes that we're going to use to classify inorganic compounds and acids. So don't worry about trying to jot this whole thing down. I'm going to have all 5 of these on the next slide. So these are the 5 common classes. We've got binary ionic, which I'll write my abbreviation, BIC. You'll see that throughout. Anywhere that you see binary, that's going to mean that the compound has 2 elements in it. So when you see binary, think 2. For binary ionic, that means you're going to have 1 metal element, and it's going to be in a compound with a nonmetal. An example of that we all know is table salt. Sodium is a metal, chlorine is a nonmetal. And what I'm making for you here is kind of a cheat sheet, okay? So either fill it out along with me, or you can print it off from the PDF after I post it. But this will help you classify compounds. The next class is the ternary ionic compounds, or TIC. And that starts with a metal, but you're going to have 2 nonmetals here. Or a polyatomic anion, which that abbreviation we haven't brought up yet, but it'll make sense as we move further into the lecture. But I want to make sure that I put it here for your overall cheat sheet, and then you can go back to it. An example of this would be sodium nitrate. The NO3 is a polyatomic anion. It's a group of atoms that have a charge. The next class is binary molecular, BMC. That's just going to be 2 nonmetals. An example of that would be water. Now we're getting to the acids. Binary acids, Ba. Again, binary means two. So you're going to see two elements here. The first one is always going to be hydrogen. When you have an acid, you always put hydrogen first, plus one nonmetal. An example would be hydrochloric acid, HCl, with the aqueous at the end. That's what that AQ is. And we'll go over all of these with naming and things like that. But I'm giving you the overview so that if you have nothing else, you at least have this as a cheat sheet. Finally, we have the ternary oxyacids. Because it's an acid, it's always going to start with hydrogen. But it's also going to have one of those polyatomic anions. And we're going to cover what those are. An example is nitric acid, and we'll talk about how to name those. Again, you have the AQ after it for aqueous. So binary means two elements. Ternary means three. Let me know when I can move on to the next slide if you're copying this down. So let me know if you're ready. We're going to put these definitions to work and classify some compounds together. Okay. Then let's go. We're going to classify some compounds. I'll work a couple of them through, and then I'll let you work through some of them, and we can kind of talk through it together. The first one, CO2. What I do initially, and I'll write our options up here. We've got binary ionic, ternary ionic, binary molecular, binary acid, ternary oxyacid. So those are our choices. I look at how many elements I have. Here I see two. And I look at whether or not the elements are metals, nonmetals, or combination. In this case, they're both nonmetals. Then I can look through the Rolodex in my brain to think about which category has two elements and they're both nonmetals. Two elements means I'm looking for something that's binary. So it has to be binary ionic, binary molecular, or binary acid. So I've already narrowed it down. Just because of the number of elements. Ionic compounds have a metal and a nonmetal, so it can't be that. And acids always have a hydrogen first with an aqueous at the end. I don't see either one of those. So it's got to be binary molecular. I'll walk through that reasoning again to do the next one. we've got two elements here. I see one metal and one non-metal. That means I've got to have something binary. So it's got to start with a B. And it has to be something that's got a metal plus a non-metal. The only thing that fits the bill for that is binary ionic compounds. So I'll give you a couple of minutes to look at these other three. I'll give you the hint because we haven't covered these yet. C has a polyatomic anion, and so does E. So I'll give you about 2 minutes, and then I'll check back in. I'll start going over these. If you're still working, that's cool. If you're just waiting for me to go over it, that's cool too. Feel free to put whatever answers you have in the chat. For letter C, we've got 3 elements. That narrows down our options quite a bit. It has to be something ternary ionic, or ternary oxyacid. Because it starts with a hydrogen, and then there's 2 other non-metals, which are polyatomic anion, and it's got that aqueous at the end, it has to be a ternary oxyacid. So just the number of elements alone can tell you, it at least narrows down your options, but it'll tell you what you're working with, and you'll have a greater chance of getting it right. Letter D. 2 elements. That narrows down our choices to binary ionic, binary molecular, or binary acid. I see that aqueous there, and it starts with a hydrogen, so it's got to be an acid. Letter E. I've got 3 elements. Has to be something ternary. Ternary ionic compound or ternary oxyacid. I don't see anything that has to do with an acid. It starts with a metal, calcium. So it has to be ternary ionic. Even if I didn't know exactly what ternary ionic compounds were, I could definitively say it's not an acid because I don't see a hydrogen and I don't see aqueous. Does everybody understand the kind of reasoning I was doing to get to these answers? That's the reasoning that you'll need to do for your exam. It's okay. Caps lock will come for you sometimes. The questions for this, some of them will be multiple choice, some of them will be fill in the blank or matching. So make sure that you can do this kind of reasoning. We'll do some more practice as we go through. The reason why we have to figure out what kind of compound we have is because that tells us how to name the compound and how to take a name and write the formula, which is what we'll be doing towards the end of the class. First, we have to build a little bit more of our naming skills. We're going to talk more about ions. We talked about cations and anions in chapter 5. We just didn't have the terminology. Cations are positive ions. Anions are negative ions. Both of these groups can be broken up into monoatomic and polyatomic ions. All that means is one atom for monoatomic or many. Polyatomic refers to a group of atoms with an overall charge. I'm going to go over this. We're going to go over each of these in detail, but I wanted to give you the overview of where we're going and how it fits in. So we're going to learn how to name the cations and the anions. Then we'll learn how to name ionic compounds and how to write formulas for ionic compounds. Here we go. We'll start with the easiest thing first. Monoatomic cations. Remember that these are positive. And they're always metals, because metals lose valence electrons to form positive ions, which are cations. That information is from Chapter 5, so it should not be foreign to you. Also, you should remember, or it should at least not be foreign, that the group number for metals, the representative metals, is equal to the ionic charge. So we're talking about groups 1A, 2A, and 3A. All of those metals, the group number is equal to the ionic charge. So we're going to have +1, +2, or +3 for our charge. The way that you name the ions is simply by writing the name of the parent atom followed by the word ion. So it's the element name, a space, and then the word ion. Example, Ca2+. You look up Ca on the periodic table if you don't already recognize it. The name of that atom is calcium. It's got a charge. It's an ion. That's it. What would I name the second one? It's the lithium ion. Lithium is the element name, and then you write the word ion. Easy peasy. But that ain't the whole story. Groups 1, 2, and 3, that's nowhere near the whole periodic table. Lots more metals than that. Many of them are transition metals. Those are the metals in that D block. And they can form multiple cations. So we can't just go by a group number there. Doesn't help. With these cases, you have to use the stock system. And that's just putting the charge of the cation as a Roman numeral in parentheses. There are some exceptions. Zinc, silver, and cadmium are all exceptions. They only form one ion. For these, you don't use the stock system. You'll also need to know your Roman numerals. I'll give you Roman numerals up to 6. If you're having issues with Collaborate, the best thing you can do is log off and then come back in. Could be your internet. And if you're not in class, I don't take attendance. Your attendance is based on what you do, not whether or not you're in class. Because some people work and they just watch the lectures and they get all their work in on time. That's perfectly fine too. Okay, brief aside. Anyhow, with naming, there's another system called the Latin or the suffix system. I talk about it in the video that's already posted. I'm not going to talk about it here because the main one that I'm going to be testing you on is the stock system. But your homework will have some stuff about the Latin system. And if you take another chemistry course, you may see that naming system. So I just want you to be familiar with it. Now I'll show you an example of how to use the stock system. It's very similar. You're still going to put the element name, then in parentheses you're going to put the charge, followed by the word ion. Really appreciate y'all trying to help each other out. So that's how we would name this ion. You write the element name, the charge in parentheses using those Roman numerals, and then the word ion. So that's the iron 3 ion. Let's do some practice. Yeah, go ahead. Yes. Exactly that. And you read my brain because I have that as an example to make sure that we know that. So for the exceptions, you just write the name of the element followed by the word ion. So I abbreviate transition metal TM. And it's a transition metal exception. When you're naming these ions, the metal ions, the question you want to ask yourself is it a transition metal? If yes, is it an exception? Those are the questions that will help you name these and know when to use the stock system and when not to. The first one, we've got CS+. Is that a transition metal? Yes or no? It's not. So it's not a transition metal. For that, The rule is you just write the name of the element and then the word ion. The name of it is cesium. The word ion. Boom, done. This bottom one, Cr, transition metal or nah? I feel like that's a new game show. Transition metal or nah? Yes, it is. Is it one of our exceptions, or do we need to use the stock system? It's not an exception, so we have to use the stock system. You write chromium, the charge as Roman numerals, and that's a 2. Oh, shoot. I don't know what I just hit there. My bad, y'all. I just got booted out. Like I'm reconnecting. I don't know what just happened.
Alright, if it doesn't reconnect,
I'm going to talk to them for a second once I get joined. Sorry about that. I got booted off of Blackboard. So I'm going to have to restart our connection. So give me 1 second here. So we just finished that one up with the chromium 2 ion. We said we had to use the stock system because it's a transition metal and it's not an exception. Hold on to that. Put it in the back of your brain because now we need to talk about anions. We'll start with the monoatomic anions. These, again, we talked about at the end of chapter 5. We just didn't have the terminology. Anions are negatively charged. They're nonmetals that gain valence electrons. To figure out the charge, you take the group number, the one that ends in A, and subtract 8. And we're talking about groups 5A through 7A. So if I had nitrogen, a group 5A element, I'd take that 5, subtract 8, and that gives me -3 for my charge. That hopefully is a review. We talked about it at the end of chapter 5. If that's not review, go back to chapter 5, then come back to chapter 6. As far as naming, it's a little bit more complicated. I'll show you how to do it with our examples down below. What you're going to do is take the element name. Here we've got N3-. N is the symbol for nitrogen. All we want from this word is the root. So we're going to get rid of that other stuff. NITR, that's kind of the first syllable, the root of the element name. Replace that, everything else, with IDE and write the word ion. So that what you have is the nitride ion. I'll show you that again. Br minus, which might be a little bit hard to see, but that's a minus sign. Br is bromine. That's the element name. We want the first syllable, so brome. Get rid of everything after that. Replace it with IDE and the word ion. So it becomes the bromide ion. Does that make sense to everybody? Okay. There's going to be a lot of bits and pieces that we're going to put all together. So you just got to hang on to them for a little bit. That was the monoatomic anions. Now we've got polyatomic anions, and that's the PAA that I was talking about before, where you have multiple nonmetals. Generally, these polyatomic anions will have an element that's combined with oxygen. So they're both nonmetals, but you'll have something and oxygen. And lots of these have names that end in ATE or ITE. For example, you have NO3 minus. That's the nitrate ion. The nitrogen and the oxygen are all sharing electrons, and their overall charge of the whole thing is -1. That's the ATE. It's got 3 oxygens. Nitrite is NO2 minus. That's a nitrogen with 2 oxygens, and they're all sharing electrons, and the overall charge is a -1. That's ITE with 2 oxygens. The ITE form of an ion will always have 1 less oxygen. So remember that rule. The ITE form has 1 less oxygen than the ATE form. And our example was nitrate with 3 oxygens. Nitrite has 2. Notice that they have the same charge. They're both -1. Different number of oxygens, same charge. So let's put that to work. We've got the chlorite ion, and it's ClO2 minus. What do you think is the formula for the chlorate ion? You can think it over and put your answer in the chat. Yeah, it should be ClO3 minus. So the chlorite has 2 oxygens. chlorate should have 2 plus 1 more oxygen. And it has the same charge. Let me know how we're doing so far. If you have a question, you can throw it up. If you're feeling good about naming, let me know that too. If you're like, struggle bus, slow down, you can let me know that too. This is a chart that has all of the common polyatomic ions. I want to draw your attention to the very first one in the table. That's ammonium. It's positively charged. So that makes this a cation. It's the only one in the table. You may see that in your homework or in an assignment that I give you. But it's still the same thing. You just write ammonium. Okay. Everything else, they're anions. And there's 2 columns of them. Don't memorize this chart. You don't have to. I will give you this chart, this exact chart, minus my scribbles, for this exam, exam 3, and for the final. So don't memorize it. We will be referring to things from this chart for the rest of the class. So if you haven't already pulled up the lecture notes from the recorded video, you should do that and pull up this table, because we'll need it. I also recommend that you print it out and put it in your notebook, or at least like bookmark it, take a screenshot, something, so you have easy access to it. Now we're getting into the naming part. Like I said earlier, you have to classify the compound so you can use the right naming rules. We'll practice identifying these and naming them as we go. And then at the very end of class, I have a few examples for us to do together where I'm not telling you what it is. You have to classify it and then name it or write the chemical formula, which is what we're also going to do. You'll have a chapter 6 check-in that's very similar to what we're doing at the very end of class to bring it all together. So if you can do the 3 questions at the end of class, that chapter check-in should be a breeze. Let's get started. We've got classifying and naming binary ionic compounds and ternary ionic compounds. Same rules for these. When you're naming any ionic compound, you're going to take the cation name and the anion name, drop the word ion, and smush them together. I'll show you what I mean. Our first one, let's classify it. Is that a binary ionic compound or a ternary ionic compound? It's binary ionic. There's only 2 elements here, 1 metal, 1 nonmetal. If I were to just name these ions, I would say, okay, this is my cation, this is my anion. The cation always comes first. When you're looking at a formula or a name for an ionic compound, the cation always comes first. I would look up Ba on the periodic table, and I'd find that that's barium, which is a group 2A metal. What would be the charge for barium? It's a group 2A metal. 2 plus because it's group 2A. It's a group 2A metal, Ba2 plus. That means we can just name this ion by writing barium and the word ion. So that's how we would name that half. Now we have to deal with the I2, the anion. I'll do that in a different color. I'd look up I, and that's iodine, and it is a group 7A nonmetal. To figure out the charge, I take that 7, subtract 8, and I get a -1 charge. So that's my ion. That's what it looks like. If I were naming that ion, start with the element name. We only want the root, that first syllable. Cross everything else out. Add IDE and the word ion to make the iodide ion. Now I get rid of the word ion from both of these and I smush them together. I want this word and this word. And that makes barium iodide. But what if it's something that's in the stock system? Copper is a transition metal. So I can't just look at it and know right away what the charge is. SO4, as you get familiar with the polyatomic anions, you'll recognize it. If I have to use the stock system for copper, I need to know what my charge is. So in this case, we'll start with the anion. If you look up SO4, that ion is SO4 2-, the sulfate ion. In an ionic compound, the overall charge of the compound is 0. So that means that the copper ions have to have a charge that's equal but opposite of what the sulfate is. I've got 2 copper ions. And when I multiply by their charge, it has to equal a +2. What do you think the charge is on my copper ion? I've got 2 of them. And when I add up those charges for my coppers, it has to equal +2. It's got to be a +1 charge. If I've got 2 ions and they each have a positive 1 charge, then that means I've got a total positive charge of +2. The sulfate has a charge of -2. If I add those two together, I get 0. We'll work more with doing this when we're writing the formulas, but I wanted to introduce it here. To finish naming our compound, we take the copper 1 and the sulfate and put it together. So talk to me. How are we feeling about this? We'll do practice, so if all you need to do is practice, that's fine. We'll clear it up with some practice. Yeah, I get it. Okay. Let's do a couple more. So we'll walk through these together. First, I want you to tell me, so we're doing this first one. Do you think this first one is a binary ionic compound or ternary ionic? It's ternary ionic. We've got 3 elements. Now I'm going to look at these and kind of figure out what they are. I see 2 nonmetals together. So that's going to be a polyatomic anion. And then I've got calcium as a cation. Find calcium on the periodic table. Is it a transition metal or no? Yeah, it's not a transition metal. So if we were going to name that, it would just be the calcium ion. NO3, if you look that up, it's called the nitrate ion. We named both of our ions. We get rid of the word ion from both of them. And we have calcium nitrate. That's a simple example. Now let's do another example where we have to figure out charge. We've got copper, Cu. Copper is a transition metal. Right, you don't do anything with the oxygen in the first one. You look at NO3 as a whole package. So copper is a transition metal. It's not an exception. So we have to use the stock system here. In order to know what the charge is on the copper, we have to look at the anion. The anion is sulfur. That's the S. What's the charge on this ion. It's a monoatomic anion. Tell me what the charge is for the sulfur. It's in group 6A, so we're going to take 6, subtract 8, and that gives us -2 for the charge. That's what the sulfide ion would look like, and that's its name. I don't think you guys have questions about naming the individual ions. It's about figuring out the charge if we're dealing with the transition metal. Is that correct? Okay. That's where we are now. I know that my sulfide is -2. So if I had one sulfide ion, it would be -2. I need to have some copper, and I've only got one copper ion in this formula. And the overall charge has to be 0. So when I add the charge from the sulfide ion and the charge from my one copper ion, they have to be 0. So what does the charge have to be for copper? It has to be +2. Now that we know our charge, we can write out the copper ion name. So we have Cu2+, which is the copper 2 ion. We're going to take this part and this part, slap them together for the name. Copper 2 sulfide. Let's do the last one. The first part is the metal. We've got silver. Let me know if it's a transition metal and whether or not it's an exception. It's a transition metal and it's an exception. It only makes one ion, and that's silver 1+. So we name it just the silver ion. PO4, that is one of those polyatomic anions. So you need to look on the sheet for that. What you'll find is that's the phosphate ion. We take the first word from each of them, get rid of that ion, and the name is silver phosphate. How do we feel about this now, from that last slide to this slide? Better? Worse? about the same. Good. So for chapter 6, I always post some worksheets and answer keys so that you can practice classifying, naming, and writing chemical formulas. So I'll be doing that today so you can have that practice. The only way to get this is by practicing. You can't just look over the rules. You have to practice using them. My second question to you all. We will likely finish this early. Do you want to just continue through and finish early? Or do you want to take a short break now? Okay. That's usually the option that y'all go for. I don't blame you. So the ionic compounds takes the longest because we have to learn how to name them, and then we also have to learn how to write the chemical formulas, and that takes a little bit more practice than the other compounds that we're going to go over. Remember that an ionic compound is composed of positive and negative ions. The total positive charge has to equal the total negative charge. We just talked about that in terms of writing the name when you have a transition metal and you have to figure out the charge so you can use the stock system. I'll give you another example to show you how the positive and negative charges work out. Let's say we had some good old table salt. Salt is made of sodium and chlorine. Sodium is a group 1A metal. That means that its charge is going to be +1. Chlorine, on the other hand, is a group 7A nonmetal. It's going to have a -1 charge because you take the group number, subtract 8, and that gives you the charge. If I looked at the charges for these, I'd have +1 from my single sodium ion, and I'd have a -1 from my single chloride ion. And when you add those together, you get 0, which is the total charge. When we're writing chemical formulas, you always want to do this check to make sure that your formula is correct. A correct formula will have an overall charge of 0. When you add all the positive charge to all the negative charge, it should be 0. Let's do some practice. Calcium sulfide. We have to take the name and work it backwards. Just like with the formulas, the cation is listed first. So you can think about this as writing out what the calcium ion is and what the sulfide ion is. The calcium ion, you look up calcium, it's in group 2A. That tells us the charge. That's the calcium ion. Sulfide, the root is sulf. You have to figure out which element that is. it's sulfur. Then you figure out the charge. It's in group 6A. So that means you take the 6, subtract 8, you get -2. Those are our 2 ions. Now, let's see what our charge would be if we just took 1 calcium ion and 1 sulfide ion. We've got 2 plus from our cation, and we've got 2 minus from a single sulfide ion. When we add those together, we get 0. That means that we figured out what our chemical formula is. It's 1 atom, or 1 ion of the calcium, 1 ion of the sulfide. Everybody with me so far? This is the easier one to do of the 2. Let's do another one together. And by together, I mean I'm going to go through it. I'll have you guys do some examples later. The first part of the name is always the cation when we're looking at ionic compounds. One of the ways you can tell that you're looking at something ionic is because it starts with a metal and it's got the IDE at the end. So metal with IDE, you're looking at an ionic compound. The cation is going to be pretty easy. We don't even need to go to the periodic table because it tells us exactly what it is. Iron is Fe, and the charge is in parentheses because it's using the stock system to write this name. So we know its charge is 3+. With the oxide, we have to do a little bit more digging. Ox comes from oxygen. That's another group 6A nonmetal. So its charge will also be 2-, just like sulfur. If I took 1 iron ion, I'd have a +3 charge. If I added that charge to 1 oxide ion, that's -2. Add those together, I get something that's not 0. Okay. That's not neutral. So our formula can't just be 1 of the iron and 1 of the oxygen. It's got to be something else. When you run into that situation, here's what you do. The number in the charge for the iron, this is our cation, becomes the subscript for the anion, our oxygen. The number in the charge for the oxide, which is our anion, becomes the subscript for the cation. So you do that swap. Then you can double check to make sure that you did it right. With this compound, we're saying that we've got 2 iron 3 ions plus 3 oxide ions, which is O2-. So 2 times +3 plus 3 times negative 2 gives us 0. We've got plus 6 and minus 6. So that checks out. And this is our chemical formula. You still with me? Okay, good. So that was a little bit more complex, where our ions were not equal. So we had to add some subscripts to have different numbers of ions to balance out the charge. We'll do another example together. Calcium nitrate. When you see something that ends in ATE, you've got a metal plus something that ends in ATE or ITE, you know you're dealing with a ternary ionic compound. Your anion is going to be a polyatomic anion from the chart. You'll have to look it up to know what that is. Now we've been working with calcium, so I'm just going to jump to the chase. It's calcium 2 plus. That's our calcium ion. The nitrate ion, you need to look it up on the chart, and when you do, that's what you'll find. It's NO3 minus. If I had one calcium ion and one nitrate ion, would I have a neutral atom or a neutral compound? Is that the right formula? No, it's not. We've got a positive 2 and a negative 1. That ain't 0. It's not neutral. Take a second, and in the chat, you can try to write out what you think our formula will be. Now, I know it's hard to write these types of things using Blackboard because you can't do all the superscript, subscript stuff. But do your best. You can tell me how many calcium ions and how many nitrite ions you'll have in the formula. As you work, I'll kind of write things out too, so you can see it if you're a little bit stuck. Notice that I put parentheses around the nitrate. That's because if we're putting a number to multiply the nitrate ion by, we want to multiply all of the atoms in the nitrate. So we put parentheses around it to treat it like a group. The charge for the cation becomes the subscript for the nitrates. Now, usually we would also say, well, you take that charge and put it here. But that charge is a 1. It's an implied 1. It's 1 minus. And we don't write 1s for subscripts. So what we would have is CaNO3 in parentheses with a 2 on the outside. And that means 1 calcium ion and 2 nitrate ions. How we doing with this one? This is about as complex as it gets. It'll take practice, but if you're like, I think I could do it with some practice, then you're in a good place. I want you guys to try this one. You've got iron 2 phosphate. And I will tell you, if you don't have the chart, what phosphate is. That's PO4 3 minus. That's what that ion is, the phosphate ion. With that information, I'll give you a couple of minutes to try to write out the chemical formula. So in 2 minutes, I'll hop back on and tell you what it is and check in with you to see if you got it. Okay, I'll start writing this one out. You can keep working if you're still working, and then you can check your answer when I'm done. I already told you what the phosphate ion is. Iron 2 tells you in the name what the cation is, iron 2 plus. If I were to put one of each of these together, I wouldn't get 0. Clearly not neutral. So I need to do our swapping trick. Don't forget to use those parentheses around the polyatomic anion. Otherwise, your answer is wrong. We'll take the 2 from the charge of the cation, and that is our subscript for the phosphate, which is the anion. We'll take the charge from the phosphate ion and drop it down for our subscript for the cation, the iron. That means that we would have 3 iron 2 plus ions and 2 phosphate ions. And that gives us 0 as our overall charge. Questions? How did we do with this one? Good. With practice, it'll get better. That's ionic compounds. The most complicated part was the ionic compounds. Everything else will be easier. Now we're in molecular compounds, and the only one that we have for that is binary molecular compounds. They contain 2 nonmetal elements. you name the elements in order of appearance. So the first one, then the second one. And the second one has the suffix of IDE. To talk about the number of atoms of each element, you use the Greek prefixes in this chart. You will need to know these. I'm not going to give you this chart. You've encountered most of these already. So make sure that you know them. Now I'll walk you through some examples so you can see how the naming works. We've got two compounds and they both have nitrogen and oxygen, but the ratio of nitrogen and oxygen is different, so they'll have different names. The first element that we see is nitrogen. There's only one of them. If there's only one of the first element, you don't use mono. But if there's only one of the second element, like here, there's one oxygen, then you write monoxide. The ox is for oxygen, and the naming of the oxide part is just like with the anions. So we took oxygen, got rid of everything except for the first syllable, and replaced it with IDE. For the second compound, we've got two nitrogen atoms. So we're going to use the di prefix, dinitrogen. For the oxygens, we've got three. So we'll use tri. Trioxide. Does that make sense? I think going through naming them makes more sense than just talking about the rules. So let me know if there are questions about that. I'm going to assume that we're good here. We'll do some practice of all of these at the end. Binary molecular compounds are pretty easy. So we're just going to move through and do the acids and a few examples of those. Then we'll do examples of everything. Binary acids. Remember, that's Ba. It's a hydrogen plus a nonmetal. And it's aqueous. We're talking about aqueous solutions. That just means in water. The formula for a binary acid will always start with that hydrogen and have AQ in parentheses at the end. When you're naming this compound, you use the prefix hydro. That's for hydrogen. Then you write the element stem, which is like the root, and you add the suffix ic and then acid. What does that mean? I've got two examples down here. We'll walk through them together. Always start with hydro. That describes the hydrogen. Next, we deal with the nonmetal. F is fluorine. We just want the root. So we're going to use fluor. follow that with ic and the word acid. I is iodine in the second one. We're going to use iode as our stem. When writing the name, hydro comes first for the hydrogen. Then we describe the nonmetal with its stem, iode. Then you add ic and the word acid, hydroiodic acid. We've got one more thing to name before we do some practice. Can I move on to the ternary oxyacids? Ternary oxyacids. You've got a hydrogen plus one of those polyatomic anions that has oxygen in it. They're also called oxyanions. You'll also still see that AQ. But when you're looking at a formula, a chemical formula, that's what it'll look like. The hydrogen with the polyatomic anion followed by AQ for aqueous. The way that you name these acids is based on the ion that the acid is derived from. So, if you have an acid that's derived from something ending in ATE, this is what you do. We have a ternary oxyacid. It's got NO3. That's a polyatomic anion. Look that up on your chart. It's called the nitrate ion. When something ends in ATE, and that's where the acid is derived from, you get rid of the 8, the ATE, replace it with ic. Get rid of the word ion, replace it with acid. For nitric acid. If you have an acid derived from an oxyanion ending in ITE, you do something very similar. HNO2. NO2 is the nitrite ion. Replace ITE with OUS, the word ion with the word acid. The name becomes nitrous acid. I'll give you a second, make sure you're all caught up with your notes, because the next thing we're doing is practicing naming of the acids, binary acids and ternary oxyacids. So here we go. Would you like to try these examples on your own, Or do you want me to walk through the first one and then let you do the other two? Okay. So I'll walk through the first one. Before we name it, we classify it, even if that's not part of the question, because you need to know which rules to use. Is this a binary acid or a ternary oxyacid? It's a ternary oxyacid, that's right. You look up the oxyanion that the acid is derived from, and that's ClO3, which is the chlorate ion. For the ATE, we replace that with ic, followed by the word acid. So the name is chloric acid. Classify the second one for me. Binary acid or ternary oxyacid? It's a binary acid. This should be a 3 here. This last one, binary acid or ternary oxyacid? Once you know the classification, you can name it. So let's go through and name these two. For binary acids, you start off with the prefix hydro. That's for the hydrogen. Then we need the stem of the nonmetal. Our nonmetal is bromine. Brome is going to be our stem. We follow that up with ic and the word acid. Now this last one, little bit of a curveball. Here we go. The ion is the phosphate ion. PO4 3-, that's the phosphate ion. Normally what we would do is get rid of the 8, replace it with IC, ion, that's acid. And then you would put it together and you'd say, okay, this is phosphoric acid. But it's actually not. I know, all these rules just to break them, right? We actually call this phosphoric acid. There are some exceptions. I'm not going to expect you to know these, but I wanted to bring it up just in case you saw it somewhere else and you're like, wait a minute, that doesn't make sense. A lot of them follow the whole, get rid of the 8, replace it with ic. But sometimes that just doesn't work. Phosphic? No, nobody's going to say that. You're going to sound stupid. Phosphoric acid. Sulfur is another example. H2SO4 is sulfuric acid. So I just wanted to throw that in here for your own knowledge. On the exam, I'm not going to throw you any curveballs like this. Everybody good with classifying and naming the acids? Good. Here's some more practice. Classify each compound and write its chemical formula. This is the last activity that we're doing. Then we have reminders and we're done. I'll give you 5 minutes to work on this, and then I'll come in and start putting some answers up. If you have questions in the meantime, you can go ahead and put it in the chat, and I'll answer it. But I want you to work on this. This is very similar to the check-in that you're going to have due on Sunday. Make sure that you classify first, and then write the formula. I see this time and time again where on that check-in, classify each compound and write its chemical formula or write its name. And you just do the formula or just write the name, but don't classify. Make sure you classify the compound. That's half the credit. So we're practicing like that in class. When you do your assignment, make sure you do it this very same way. Classify first, and then give me the formula or the name. All right, off my soapbox. 5 minutes, and then I'll check back in. All right, y'all. It's been almost 5 minutes. It's like 4.5 minutes. I'm going to start walking these through. For classifying, we've got 5 options: binary ionic, ternary ionic, binary molecular, binary acid, ternary oxyacid. Iron 2 oxide. How would we classify that? I agree. This one is a binary ionic compound. It's got a metal, and you see the IDE at the end. So you've got one metal, one nonmetal. Now we have to write the formula. Iron 2, well, that tells us exactly what it is. It's Fe2+. Oxide comes from oxygen. Its symbol is O. We've gone over figuring out the charge several times, so hopefully we're okay with that. But just in case, one more time from the people in the back. Oxygen is in group 6A. To determine that charge, you take 6 minus 8. That gives you a -2 charge. If I put one of each of these together, I'd get 2+ and 2-, which would give me 0. So our formula is simply one of each ion, FeO. Second question, we've got phosphorus trichloride. How do we classify that? It's binary molecular. Here's how you can tell. One of the biggest giveaways is that prefix tri. You only see those with the binary molecular compounds. Also, you've got phosphorus and chlor, which is for chlorine. Those are two nonmetals. Again, the only classification for two nonmetals is binary molecular. Then you just translate that name into a formula. Phosphorus, we don't see any prefixes, so there's just one. Chlor is our root here. That's for chlorine. Tri tells you there are 3 of them. That's our compound. The third one, we've got calcium phosphate. What's the classification for this compound? Calcium is a metal. So we've got a metal. And we see something ending in ATE. That says that it's some kind of a polyatomic anion. So it's a ternary ionic compound. Writing out the formula, calcium is a group 2A metal, which means its charge is 2+. Phosphate is one of those polyatomic anions that you look up. 3- is its charge. The charges of these two ions, 2+ and 3-. That means we're going to have to use our swapping trick. If I have 3 ions of calcium and 2 phosphate ions, then I should have an overall 0 charge. And that's what I get. Don't forget to use those parentheses around your polyatomic anion if there's more than one. Questions? Then here's your reminders, and then we're done. Chapter 6, you're going to have a check-in. It's going to be posted on Blackboard today in that Chapter 6 folder. So look at that. I'll put out an announcement when it's up. You've also got Mastering Chemistry Chapter 6 assignments. All of that is going to be due on March 14th. The chapter check-in will be very, very similar to what we just did. It'll be 3 to 4 questions, and you'll have to classify and either write the name or the chemical formula. Next week, you have exam 3. That covers chapters 5 and 6. We'll do some review next week, and then we'll start chapter 7. Your exam will be available Wednesday, March 17th through Friday, March 19th. Again, it's really concepts. So you'll be doing matching, naming, which the naming, I'm going to make that multiple choice. It's not a spelling exam, so as long as you understand the rules, you should be able to do okay. We'll go over that next week. I'll post the exam review like usual, and we'll go over some of those questions in class next week. That's all I have. If you have questions, hang around and ask. If you don't, you're free to go. We finished up about 30 minutes early today.